All right, let's look at example 2 now. So first of all, what exactly do we mean by factoring? Well, factoring just means unmultiplying, or like taking the result of multiplication and writing it as multiplication. So for example, if I said to factor 6, you could take 6 and write that as the result of multiplying 2 times 3. That's factoring the number 6. If I said to multiply 2 times 3, that would be take 2 times 3 and turn it into 6. So to factor y squared minus 5y minus 6, that means this is the result of multiplying two binomials. So let's say you have y plus yellow thing times y plus blue thing, for example. When whatever the yellow thing and the blue thing are, let's see what happens when we FOIL this out. We're going to get y squared from doing the y times y. We're going to get a plus yellow thing times y, whatever that is, plus blue thing times y, whatever that is. It's the outer term. And then plus whatever yellow thing multiplied by blue thing is. And we know that these things must add up to be 5y, right? And, or excuse me, negative 5y. And the two things that are just the numbers should multiply to make negative 6. So we want two numbers that add up to negative 5. And we want to multiply them to get negative 6. And if you try some stuff for a little bit, you might be like, okay, what about negative 2 plus negative 3? That comes out to negative 5. But then when you multiply negative 2 times negative 3, that makes positive 6. So that doesn't quite work. So if you try something else, you might come up with, how about things that multiply to make negative 6? What if we do negative 6 times 1? That's negative 6. And negative 6 plus 1 is negative 5. So that's what we want these to be. Negative 6 and 1. And so that's kind of the idea behind factoring. With a regular old binomial, excuse me, this is a trinomial, excuse me, with three terms, where you have something squared, and there's no number here. It's just like 1 times y squared. And you want to find two binomials here, where the other number here that you have, like one number and another number, should multiply to make the number by itself, and they should add up to make the coefficient of y, the linear coefficient. All right, how about with b? This doesn't work so well here because like it's a little confusing, but there's a trick here. Is you always want to start by factoring out common factors. All of these have a 2 in them, and they all have an x in them. So the first thing you can do is write this as 2x with whatever's left over. So we can do 2x if we distribute this into these three terms that are left over. It could be, let's see, 2x times x squared gives you 2x cubed, minus 16x, and then plus 64. Yeah, so 2x times 64 would be 128x. So that has been factored, but it's not completely factored because you can break it down further. Because as long as you have an x squared here, you can probably most of the time, factor out the factor with x squared further. So what we need is we need two numbers. Like, we know we're going to have an x and an x here to start, because the x times x will make that x squared. But then whatever goes over here, those two numbers, just like with the last one, you can add them, and so you're going to do like the yellow 1 times x plus the blue 1 times x. That should add up to negative 16, and you should be able to multiply them to be 64. And if you try, there's a few different ways to multiply things to get 64. You could do 32 times 2. That doesn't add up to 16. You could do 8 times 8 is 64. But then 8 plus 8 is positive 16. Oh, but wait, a negative 8 times a negative 8 is positive 64, and then it adds up to negative 16. So after trying some stuff, you'll come up with that, hopefully, and so I'm going to write, instead of writing plus negative 8, that's a little awkward, I'm going to write x minus 8 and x minus 8. Okay, and you could also, of course, just write that as 2x times x minus 8 squared. All right, let's look at this one. So, same idea here. We're going to have a binomial with b and another one with b, because I know these are going to multiply together to make that b squared part. And then we're going to have two numbers here. And those two numbers you can add together to get 2, because we're going to do the yellow 1 times b plus the blue 1 times b, and they are going to be multiplied to make negative 24. So when you do that part, that should come out to be the negative 24. So you can think of some factors of negative 24 that might work. Let's see. How about negative 24 times 1? That doesn't quite work. One of them, well, if you try to add them up, negative 24 plus 1, that adds up to negative 23. You could try negative 8 times 3. That multiplies to make negative 24, but those add up to 5. Okay, let's try one more. How about negative 6 and 4? Oh, that works. Negative 6 plus 4 is 2. So I'm going to write this as b minus 6 and b plus 4. And remember, it's a good idea to check this out by foiling. Work it out as b times b is b squared when you FOIL that part. Then we'll have a minus 6b and a plus 4b, and then negative 6 times 4 is minus 24. Oh, wait. It's a good thing I checked it, because this comes out to be negative 2b. Okay, so that was not quite right. I messed up. Negative 6 plus 4 is negative 2. So this should be, how about 6 and negative 4. So plus 6 minus 4. If you FOIL that out, that will become plus. This one will become minus. And that should work. All right, so that is the answer here. It's always a good idea to check it. One of the reasons why it's really important to check this is because foiling it out again, make sure you understand why it works. Like, if you're just following the steps, like I said, to find two numbers that multiply to make the constant term and add up to make the linear term, and you're just following that step because that's what I said to do, then you're going to forget it pretty quickly. By the time the final exam comes around, you're not going to remember those instructions. The thing that will really make a lasting understanding to understand why this works is to get a lot of practice foiling it out. Like, if, for example, if I said to factor 6, you really need to have a lot of practice knowing how to multiply things to know that that's going to be 2 plus 3. The same thing is true with these more complicated expressions here. To understand factoring, you really need to understand multiplication. So it's really good to practice that by foiling stuff out as much as you can. All right. So yeah, let's look at part D here. We've got x squared minus 5x plus dx minus 5d. How's this going to work? This doesn't really have the same format as these other problems. These other ones had 3 terms. This one has 4 terms because it's got 2 variables involved. So what do you do here? Well, the trick is we're going to do something called factoring by grouping. There's a group here and a group here, where each of those groups has something in common. Like this group has an x in common. So I'm going to write that as x times x minus 5. Factor out the x from those. And then this over here, both of these terms have a d. So you can take out the common factor from those, and you'll be left with d times x minus 5. Like so. And now, these 2 terms have a common factor of x minus 5. So, just like if you had, I'm going to do a little example on the side. If you had, let's say, x times a plus d times a, you could factor that out as x plus d. I think I'm going to go out of the frame here. X plus d all times a. You could just take out the a from it, right? Well, here you have x minus 5 and x minus 5. You can factor that out. And what's going to be left over is x plus d. So that has now been factored out. And this is the factored form. You have x plus d times x minus 5. And if you wanted to check this, it's a good idea, like I was just explaining. Do x times x, let's FOIL it out. That's going to be x squared plus, let's see, x times negative 5 is the outer term. Plus d times x minus 5 times d. And that is the original thing. So that is called factoring by grouping, is this process here. And that is a handy trick, because what about situations when the quadratic coefficient, the coefficient of x squared, isn't 1? Like with all of these ones, like when you just have y squared, you can just pretend that's 1y squared and 1b squared. And here you had like 1x squared in there. It started out with a 2x cubed, but once you factor out the 2x, you just have 1x squared left over. So in those cases, you know that the 2 parts of the variables, you're just going to have like 1y and 1y and 1x and 1x, because those are what's going to multiply together to make x squared. But when that isn't 1, like let's look at these examples here. Like example 3, you have a 4 times m squared. Here you have a 36y squared. Here you have a 4x squared. So what do you do? Do you freak out? No, well, you can freak out if you want to. But There's a more complicated method that we're going to learn for how to deal with these situations. So the first thing to do is always going to be to factor out all common factors. So a common factor would be like one number that goes into all the terms. We took out a common factor of 2x over here. 2x was a common factor of the whole thing. That was the first step. So that's always the first step with any kind of factoring thing. And then in the remaining expression, let's find two numbers that multiply to give a times c. Oh, this is supposed to be a c here. So I'll have to fix that. So this is supposed to be ax squared plus bx plus c. So you need two numbers that multiply to give AC and add up to B. And then, after you find out what those two numbers are, we're going to break the BX term into two terms using the results of that previous step. And then we're going to factor the four terms by grouping. And the fact that this actually works out so that following these first three steps allows you to factor by grouping is something that's kind of cool. So let's see how that works here with this example 3. So first of all, is there a common factor? Well, okay, so 4 has factors of 2, 4, and 1. Oh, but then you have 19 is actually a prime number. That doesn't have any factors of anything other than 19 and 1. So there's no common factors. So then we're going to find two numbers that multiply to give a times c. So in this case, the a times c is 4 times 12, which is 48. So we want two numbers that we can multiply together to get 48. And then they need to add up to 19, the b. That's what this second step is. So we got to figure this out. So let's see. Well, 48 is 4 times 12. Does that work? Well, unfortunately, that adds up to 16, so that doesn't quite work. You could, and so this is a trial and error. You got to try some stuff. If you do 48 times 1, that adds up to 49, so that doesn't work. We could do, let's see, 16 times 3. Does that add up to 19? Yes, it does. So that sounds good. So that tells you how to break down the middle term. So I'm going to rewrite the whole expression here with 4m squared plus 16m plus 3m. And you can do that because they add up to 19. So here I am with the original thing here. And now let's try to factor this by grouping. So let's see, what do I have in common with the first two terms? Those both have a factor of 4 and a factor of m. So you can write that as 4m times m plus 4, like so. That works. If you 4m times m, you get 4m squared. 4m times 4 is 16m. Okay, so over here, we have a 3m and a 12. So what do those have in common? Well, 12 is 4 times 3. 3m is m times 3, so you can write that with a 3 factored out, and you'll have m plus 4 left over. So now that these both have an m plus 4 in them, you can factor it out. And that is now factored by grouping. Now, if you're not sure, like if this process seems weird to you and you don't have confidence in what you just did, that's all right. Just when in doubt, write it out. We're just gonna FOIL this out. We're gonna do 4m times m. That's 4m squared plus 3 times m plus 4 times 4m is 16m plus 3 times 4 is plus 12. And that gives you, let's see, 4m squared. So 3m plus 16m is 19m, and 12 is 12. So that checks out. All right, and kind of short on room here, so I'm going to get rid of that. Okay, let's try to follow this process here with this one. So first of all, is there a common factor? Well, let's see, 25 is 5 times 5 is the only way to factor that. But 5 is not a factor of 36. So there's no common factors here. So what we can do is the same process as before. I'm going to write the a times c over here. So a times c is 36 times 25, which is 900. We want to get that as the result of multiplying two numbers. Then and the b here is just 60. So we want to get 60 as the result of adding these two numbers. So let's see. This is a tricky one. 900 is, let's see, 90 times 10. That doesn't work. Those add up to 100. So it's not that. Let's see. Oh man, I have to think about this one. How about 30 times 30? That makes 900. And then 60 is 30 plus 30. So that works. So that tells you how we're going to split up the 60y part. All right, so now that that's done, we've now broken down the middle term, by, 60y, into two terms using this result. Now we're going to factor the rest by grouping. So to factor this by grouping, let's see, what do we have in common over here? They both have a y, and they both have 6 as a factor. You can factor out a 6y. We have y plus 5 left over, 6y times y. Wait, oh, that's not right. How about 6y times 6y makes 36y squared. There we go. And 6y times 5 is 30y. So we got that one. And then let's see, what do these have in common? We got 30y and 25. Those both have a factor of 5. Oh, and 30 is 5 times 6. So 5 times 6y makes 30y. 5 times 5 makes 25. So lo and behold, this works out that you can factor this by grouping here. And so I can factor out from these two big terms a 6y plus 5. They each have that common factor of 6y plus 5. And what's left over is 6y plus 5. So this is also known as 6y plus 5 squared. And why did I want to write that this is 6y plus 5 squared? Is because there's actually a shortcut to this. Especially when you have big numbers like this, you might notice that this is a big pain, what we just did. And what is the shortcut here? Well, let's remember we had this formula before. This is what I said was a really important formula that you want to memorize eventually. X plus r squared is equal to, here we go, equal to x squared plus 2xr plus r squared. And what we have here, the 36y squared is, I'm gonna write this in red so it's distinguishable from what the work I did before. So we have 6y squared, that whole product squared is the same as 36y squared. And 25 is 5 squared. So that's kind of like the x is 6y, and the 5 is r. And what if you had the 2x term here, 2xr term? That's going to be 2 times x is 6y here times 5. And 2 times 6 times 5, yeah, that makes 12 times 5 is 60y. So this is actually in this format, where we have the x squared plus 2xr plus r squared. So if you can see that's what you have here is x squared plus 2xr plus r squared, you can just go straight from there to writing it as x plus r squared. And that is a thing that we're going to need to do more later. For right now, it's a little advanced, but if you can use that as a shortcut, that's a great idea. Okay, and this one actually has a shortcut too. If you want to pause it and try to do part C here using one of these factoring rules from before that were in that box, give it a shot. But I'm going to work it out. So I'm going to do this following the same steps here. First of all, is there a common factor between 4 and 9? No. 4 is 2 times 2. 9 is 3 times 3. So you can't take that out. But what you can do is follow these steps. So let's see, the a times c part here. The a times c for part C is 4 times negative 9, which is negative 36. So we want to find two numbers that multiply to make negative 36. And the b here is 0. So we need to get two numbers that add up to 0, but multiply to make negative 36. So if they add up to 0, they have to be opposites, right? Like 5 plus negative 5 is 0, or 10 plus negative 10 is 0. But if you want to make them multiply to make negative 36, well, let's see. 6 times negative 36. Oh, wait, sorry. 6 times negative 6. There we go. That is negative 36. And 6 plus negative 6 is 0. So, yeah, I could write this as 4x squared plus 6x minus 6x. That still adds up to 0. And then the minus 9, leaving that there. So let's see. 4x squared and 6x, what do they have in common? They both have a 2x term. And so you can, what's going to be left over in here after you factor out that 2x is going to be, let's see, 2x. 2x times 2x is 4x squared. And then 2x plus 3 is going to be plus 6x. And then over here, what do these both have? Negative 6x and negative 9. Those are both negative, so you could take out a negative thing. And 6 and 9 each have a 3 in them. So you can have negative 3 times 2x makes negative 6x, and negative 3 times positive 3 makes negative 9. So this is the common factor in these two big terms now, 2x plus 3. So you can write this as 2x minus 3 times 2x plus 3. And that is the answer to this one. All right, so if you try to do this using the shortcut rule, the shortcut here is that a plus b is always equal to a plus b times a minus b always works out to a squared minus b squared, if you were to FOIL this out. And in this case, we started with the a was like 2x. 2x quantity squared makes 4x squared. Minus, well, we had minus 9, that's the same as minus 3 squared. So that's what we started with. And so if we're using this rule, we could just write it as 2x plus 3, that's the a plus b, and 2x minus 3. Like so. So that's the shortcut. You don't have to go through this whole process every time. And knowing these shortcut rules is a really good way to do it if you can. All right, so you have some of these to try on your own. These are tricky problems. Do your best, give them a shot. If you're stuck with them, what I want you to do for these exercises is make sure you make at least a few guesses and check your guesses by foiling out. If you're struggling to factor, then use it as an opportunity to get practice multiplying. And if it multiplies out to something other than this, that's okay. You're still getting good practice multiplying. And I'll see you in the next video. I guess I won't see you, but I will talk to you in the next video, and you will hear me talking, and I'll see you hopefully in online office hours and all that. So good luck with these difficult exercises.